Hello, Brainly Academy families. In this video, we are discussing about the difference between thermal uh, specific capacity and thermal latent heat capacity or latent heat generally. So we are discussing that the difference between the two, and we will solve this problem at the end. So let's start with the difference between heat capacity and latent heat. Let's differentiate the difference between the two, and we'll come to the problems. Let's start. So when you heat one thing, so in add heat a process. It is a process of adding thermal energy. So if we heat up something, heat up something, two things will happen. Two processes will happen. The first thing, the heat added to the system or to the body or to the substance may change its temperature. So the first thing, it will change its temperature change layer geçiyor, so it may change its temperature. And the second thing, it may change its phase. Change its phase. So how does it do this? Look, when change temperature happen, what will happen is that there is a substance, there's a particle in the body, and this body will vibrate more and more when if the thermal energy is added. So in that case, the temperature of the body will increase. And during phase change, the particles were vibrating. For example, if it was solid initially, so at certain temperature, like for 0 degrees centigrade for ice and 100 degrees centigrade for liquid water, at 0 degrees centigrade, the bond between the ice particles start to break. So the bond will start to be broken. So that time the phase change occur. Look, during change in phase, there is no change in temperature. So the change in temperature will be zero during phase change. And during temperature change, there's no phase change. Phase change, zero ይሆናል ማለት ነው. During this time, the change in phase will be zero. See, there's no change in phase. So generally speaking, so uh, the heating up process will do two things, that are a changing phase or temperature change. And the temperature during phase change, there's no temperature change, and during change in temperature, there's no phase change. That's all the general that we have to know. So if there is a temperature change, we'll use a specific capacity, which is the amount of energy that we need to change the temperature of an object by 1 degree centigrade, which is C of the object substance specific capacity times the change of temperature that is induced to the body. While during phase change, we'll use in order to find the amount of thermal energy that's added to change the phase, which is mass of the object substance times the specific latent heat. It can be latent heat of fusion or vaporization if it is from liquid to gas. Okay, let's go back to the problem. All right, so the problem says how much heat energy is required to change a 5 kilogram of ice. Look, 5 kilogram mass is how much? Mass of the body is 5 kilogram. It's 5 kilogram. 5 kilogram, just 5 kg. Mass is 5 kg, and the temperature was initially negative 20 degrees centigrade to water at 10 degrees centigrade. So the temperature of the body was increased from negative 20 to 10 degrees centigrade finally. And these constants are given to us. The specific capacity of water was 4,200 joule per kilogram degree centigrade, and for that of ice, it is 2,100 joule per kilogram degree centigrade, while the latent heat of fusion of ice is this much. Let's solve it. Now look, if we draw a diagram of temperature change of this object as thermal energy is added, we will obtain this one. So it was initially negative 20 degrees centigrade, see, and this ice will change this phase at 0 degrees centigrade, because there are three phases that we have. So if we have solid, liquid, and a gas, so this is sublimation will occur, and the deposition will backward, and this is called fusion. The fusion curve is this here. Here is a fusion from solid to liquid, and solid ice will change to liquid water at 0 degrees centigrade. So this temperature will increase until 0 degrees centigrade. At 0 degrees centigrade, it will stop. It is temperature increment. Temperature increment will cease here, and the phase change will keep on. So thermal energy add ብናደርግም በዚች ፖይንት ላይ at this on this region only phase change ነው የሚፈጠረው ማለት ነው። Here it is MC while C is ice now whose temperature is increasing, temperature of ice is increasing. So the thermal energy that we add will increase the temperature of the ice. It will increase temperature of the ice initially and change the phase of the ice from 0 degrees centigrade at 0 degrees centigrade without changing the temperature. Then later on, the temperature was increased from 0 degrees centigrade to 10 degrees centigrade final of 10 degrees centigrade. So this is what will happen to 10 degrees centigrade. So here again, there is a change in temperature. Well, there's a change in temperature here. There's a change in temperature here. But here there's no temperature change, so the phase change has happened. Now let's do one by one. So first part. Let's start from the first part, Q1. So which is the first one? It's here. So which is delta T. Delta T. So mass of the ice times C of the ice. Why we use C of the ice? Because whose temperature is increasing in the first phase? Is temperature of ice. So delta T that happened, which is equal to 5 kilogram times ice is the specific capacity of ice is 2100 joule per kilogram degree centigrade times the temperature is, so the temperature difference is 0 minus of minus 20 degrees centigrade. So when we multiply this, I think degree centigrade will go away with degree centigrade kilogram by kilogram. So when we multiply this, I hope we obtain 2.1 times 10 to the power of 1, 10, 5 joule. We'll obtain this thing. So at the end, we will obtain this. This is the first temperature, is thermal energy that is required from negative 20 degrees centigrade to 0 degrees centigrade. Now we are at 0 degrees centigrade. But at 0 degrees centigrade, so this much of amount of thermal energy is required to increase the thermal energy from the first one. So Q1, which is Q1, so from since 20 degrees centigrade to 0 degrees centigrade. Increase ያደረግነው by adding this one, 2.1 times 10 to the power of 5 joule of amount of energy is required to increase that much. Now let's go to the second part. Yes, let's move on. Let's solve the second phase of energy that is required to increase the temperature. Actually, not change the phase of the ice to liquid from 0 degrees at 0 degrees centigrade. So it will stay at 0 degrees centigrade and the temperature will never change, but then the phase of the ice will change to liquid in the second phase. Now the Q2, which is here the temperature doesn't change. The only changing thing is the phase of the ice from ice to liquid at this phase. So mass of the ice times the specific capacity of the ice, latent heat of fusion. I mean, I didn't, sorry, I said like specific capacity, but just the latent heat, specific latent heat of fusion of ice, which is 36000 joule kilogram per kilogram, which is equal to mass of the ice was 5 kilogram. You see, 5 kilogram times 336,000 joule per kilogram. That's it. This much. So kilogram will go away with kilogram, so which is the amount of heat here required here, and this will be, I think, well, 16.8 times 10 to the power of 5 joule. This will be the specific, I mean, the latent heat that we need. See, this latent heat of fusion, latent heat. It's latent heat. So it's a heat capacity that required to change. Now, the temperature wasn't changed from 0 degrees centigrade. It was still 0 degrees centigrade. Temperature is 0 degrees centigrade. But here's this amount of energy is required to break the bond between the particles. And so it will be changed to the liquid water. So from solid ice to liquid water. So how much amount of energy? So 1.16.8 times 10 to the power of 5 joule. This amount is required. Now, let's move to the third phase where the temperature again increased from 0 degrees centigrade of liquid water to how much? 10 degrees centigrade finally. Let's do that also. All right, so here's the temperature of the body changed from 10 degrees centigrade to 0 degrees centigrade to 10 degrees centigrade finally. So the temperature is raised, the temperature was changed. So we'll take the considerations as specific capacity Q3, which is mass of the body, mass of the water. So still is because it is liquid now, but since mass is conserved, we will not change the mass. The mass will be the same. C of liquid water times specific activity times change in temperature from here to here. There is a temperature change of 10 degrees centigrade because 10 degrees centigrade minus 0 degrees centigrade is 10 degrees centigrade. Now look, mass is 5 kilogram. 5 kilogram times specific capacities of water, liquid water is this much, which is 4200 joule per kilogram degree centigrade times then finally the change in temperature, which is 10 degrees centigrade. Now look, this will be kilogram will cancel kilogram, and degree centigrade will go away with degree centigrade, and so when we multiply this, I hope we will obtain 2.1 times 10 to the power of 5 joule. This is the amount of energy that we carry. So through all this process, the amount of energy that we require to increase the temperature of this body from negative 20 degrees centigrade, we have to pass through all these phases. So the total Q total energy that we require to change the temperature of this object from negative 20 degrees centigrade to 10 degrees centigrade is the sum of these all three temperature thermal energy. So Q2 plus Q3. So let's add them together. Uh, let's add them. So I don't need this anymore. So let's add them. So the sum will be the total thermal energy that required to change the temperature of this object from negative 20 degrees centigrade to 10 degrees centigrade, finally the water. So the Q total will be the sum, so which is 2.1 times 10 to the power of 5 plus 2.1, which is a Q3. Q3 is here. Here we have it. Q3 2.1 times 10 to the power of 10 to the power of 5 plus 16.8 times 10 to the power of 5 joule. So this will be joule at 8 finally. So when we add this, is 4.2 plus 60.8 is 21.0 joule times 10 to the power of 5 joule, which is finally 2.1 times 10 to the power of 6 joule. This amount of thermal energy that we require at the end to change the temperature of this body from negative 20 degrees centigrade to 10 degrees centigrade. So here I point out there are two thermal energy, two form of thermal energy change that occurred: the phase change and the temperature change. Thank you very much. So the answer is this one.